प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती जाड्यापहा.
A very good morning to all of you. Very dynamic, Honorable Director of Allahabad Education Institution, Professor Prem Kumar Kalra, our very own Member Secretary, Professor Rajiv Kumarji, all other coordinators who are attending today's program, and my friends from academia. Every Monday I speak, and every Monday I ask myself a question as what can I really speak about same faculty development programs, which almost every Monday I have been addressing too. But then I realize that faculty development or ensuring that we have committed, we have faculty members who are not only committed, but they have core competencies is probably one of the single most important thing in case we want to have much better quality deliverance in our technical education institutions. I have always been repeatedly saying it that our entire ecosystem of learning has changed. It has become multi-institutional, multi-directional, highly collaborative, and not only two-directional, but multi-directional, where students are equal partners, not as mute spectators of receiving that knowledge, but also equal partners in creating that knowledge. So when we have this kind of learning teaching ecosystem, with disruptive technological advancements, it is what is primarily needed out of us. So what is needed is that we keep on learning. And in fact, my last Monday address, I had said it, that the World Economic Forum, in consultation with McKinsey, carried out a research, and where they have declared that this time, when over 1 billion jobs has been lost in past 2 years to technological disruptions, it is a re-skilling emergency. When we talk about re-skilling emergency, it means it is an emergency where we all need to look inward and understand what it needed out of us in today's context, in today's availability of technology enabled teaching, learning, or if I may say, way of life. So learning itself a skill, unlocking the mindset and skills to develop, it can really boost personal and professional lives and deliver a competitive edge. The call for individuals and organizations from both to invest in learning and development has never been so more demanding than this time. And I have already said it, that it has become a re-skilling emergency. AICTE, in its endeavor to ensure that quality education is delivered, has taken several initiatives. ATAL, we very fondly call it. It is AICTE's Training and Learning Academy. It is an in-depth faculty development program where faculty members are trained in various core and niche areas, be it IoT, be it machine learning, robotics, blockchain management, and artificial intelligence, virtual and augmented reality, and so on and so forth. We have another faculty development program where our faculty members are trained on pedagogical skills. They are trained on newer set. They are trained on assessment patterns. So now when we talk about learning, so what is it which is required? You know, this particular article, which I have been talking about for past 2 weeks by McKinsey, and supported and funded by the World Economic Forum, it says that decade of research experience working as talent and learning professionals. It explores the core mindset and skills of effective learners. People who master these mindset and skills become much more better learners, and they have coined the word from them, they become intentional learners. So what is that? We need to have that intentional learning mindset. It has to be a core, structured, designed mindset where our faculty members tell ourselves that they need to learn. They need to learn continuously, comprehensively. They need to learn their core subject. They need to learn their delivery mechanism, their instructional mechanism, their attitude. They have to be even mentors. They have to be psychometrically available to all the students to make sure that their students are groomed into holistic individuals. So when we talk about becoming absolutely intentional learner, so unlocking intentionality, formal learning opportunities account for a very small percentage of learning of professional needs. And this is one such thing where we need to have a structured learning in a matrix of pre-decided 5 days course where our experts have been training and teaching our faculty members in the core and niche areas. So we have to foster learning by adjusting our critical mindsets, continuously telling ourselves that we need to learn, we need to innovate, not for progress, not for future, not for development, but for our sheer existence and continue to remain relevant in today's availability of paradigm shift in teaching learning mechanism. So we need to adopt a growth mindset. AICTE has been doing wonderfully well. This ATAL Academy, sir, if I may tell you, and to all our coordinators, it was recognized worldwide for granting and training highest, largest number of teachers last year. And this year, our objective is that we would at least be training 2 lakh faculty members. But AICTE can only work effectively, much more efficiently when our coordinators make sure that these faculty development programs are actually carried out with earnest honesty and with absolute dedication, leaving no room for lethargy or any kind of backlit or laid back attitude where learning has been compromised. So our entire focus is on learning. I call upon all of my coordinators and request each one of them that they must make sure that in this endeavor of AICTE, with their complete dedication, they ensure that our faculty members are trained in the core competencies with world-class experts. Now we would be very, very eager to listen to our member secretary, sir, and our honorable Kalra, sir. With these, I once again request each one of you, all my faculty members, to make sure that they really, really learn, give us valuable feedbacks. We are also trying to do a peer review assessment of all these faculty development programs to ensure that these are actually quality development. Thank you so very much, and all the very, very best to all our faculty members who are attending these faculty development programs. Now I would request our member secretary, Rajiv.
which has been inaugurated today. My friends from AICTE, Mamta Rani Agrawal ji, Dr. Amit Datta ji, Dr. Girdhari Lal ji, faculty members, very warm good morning to each and everyone. As you know, and as already pointed out and shared by our advisor, Mamta Rani ji, that last time we set an world record by conducting and by training around 150,000 faculty members. And this time the target is even larger. Now, when the target is larger, then there are challenges also. And challenges in terms of quality, in terms of involvement of the faculty, because a lot of online programs are being conducted, not only the FDPs, everywhere, every university, every institution, they are conducting various type of activities where it is classes. So online programs, they have become a challenge also to maintain the quality and to keep the attendance and as well as involvement of the participants in such programs. So that is a challenge also for AICTE as well as for all other institutions and the coordinators also. So for that, I have a simple suggestions, and that we have exercised in various other faculty development programs. We are conducting faculty development programs for human values. We are training our faculty to conduct induction programs and to run human value programs in their university. So what we have identified, we have taken, there is a provision in each and every platform to give a small quiz, just to keep our participant attentive, whether they are in the program or where they are paying more attention to the program, or they are at all not putting any attention to this program. So there is a provision of quiz. So my request to all the coordinators that they can plan, they can give a small quiz, maybe a trivial one after 20 minutes, half an hour, 35 minutes, they can decide on their own. And that will make all the participants attentive, and they will also think that anytime the quiz may come. And the participation in quiz ensures the attendance of the participants in the FDP. So this type of methodology can be utilized or adopted by our coordinators, and they can also innovate and they can find out how they can involve their faculty members. But the definitely challenge is very, very big. And as far as quality is concerned, content should be of the international standards, because most of the faculty, they have already attended one part of any of the faculty program. So now they are aspiring for the better quality, better standard of the program. So our coordinators, they have the challenge now to ensure the quality of the contents and the quality of the speakers also. They have to have more speakers from the industry, because this is also a challenging task to arrange faculty members for resource persons from the industry. So my appeal, my request to all the coordinators, please try to have speakers, resource persons from the industry. And if you can bring some part of the, you cannot bring the hands-on part, if you can show some videos on that application of that content, then it will make more enjoyable to our participants. Apart from these faculty development programs, we have taken various initiatives. We are sharing on each and every platform, and one of them is the writing of books in regional languages and translation of the books. This year, Professor Kalra, I would like to share, we have given permission to run technical programs in the regional languages, and few institutions, they have come forward. We have given permission to them, but the problem was contents, material. So we have taken that initiative. We have ensured that first year books, before the commencement of the next academic session, they are available to colleges and to our students in their languages in which they want to continue their studies. So this initiative we have taken. We have also developed a tool which we call translation tools, where we are converting these lectures on SWIM in the regional languages, where in all regional languages. So that initiative we have, and we are at the advanced stage in this this translation. Apart from that, another initiative that AICTE has taken, that is the teachers training program. So there are two types of this program. One is the teachers who are entering in the technical education. Within 5 years, they have to complete that teachers training program. In this teachers training program, there are 8 modules. And these modules, they are taken over. They have been prepared by the knitters. 4 knitters in the country, they have prepared these knitters, and they are available on our as a MOOCs courses. They are available as a MOOCs courses, and the examination of these 8 modules, it is conducted by the NTA, National Testing Agency. So these 8 modules, basically, they are teaching pedagogy and examination, conduct of ethics, and all such things. They are the part of the modules. So this is first part of this comprehensive teachers training program. Second part is that they have to do some internship for 1 month in a nearby industry. And third part is that they have to teach under the mentorship of some senior faculty members. So after completion of all these 3 parts, we are giving them a certificate and they are eligible for their further promotions. But those who have already completed 5 years, for their further promotions, we have also designed these some MOOCs courses. The knitters, they are working on that, and very soon we are going to launch these MOOCs also. So for further promotion from assistant professor to associate professor to professor. So all such modules, they are going to be ready, and we are going to launch these modules very soon. So this was the another thing. And for the faculty members, we have instituted one award, that is Vishwakarma Teachers Award, Best Teachers Award. And last year we awarded, nationally we awarded 12 teachers from the technical institutions. Basically, there are 25 awards, but we are not compromising. We have decided, unless until the teachers, they qualify our parameters, we will not select for the award. So this year the process is on. Soon we will award this, we will declare this Vishwakarma Best Teachers Award also. And another big initiative that we have taken to empower our students, girls students, that is the Pragati Scholarship. We are providing a scholarship of 50,000 per annum to our girls students, those who are entering in the technical education. There are seats earmarked for each and every state, and I request all the coordinators and the directors, those who are attending this program. This year we got very good response, because we are not disseminating this information to our students. But this year the response was good, and we were able to disseminate this information to the deserving girls students. And we have already awarded this scholarship. Probably girls from your institute might have received this amount, 50,000 in their bank account. Another initiative that AICTE has taken, that is the internships. And on 25th, we are celebrating internship day also, where we have prepared a portal where government departments, small company, MSMEs, and the large companies, they are posting their internship, and it is a matchmaking type of portal. Students get internship of their choice in their in their place of their choice, as well as in the area of their choice also. So this type of portal is available, and we are celebrating internship day on 25th. I request through this medium, please join this internship day and see what is happening, how you can facilitate your students in providing the internship also. And apart from that, various things which have been mentioned in the this NEP, they have been incorporated, and we have started most of the things 3 years back also, and now they are part of the NEP. And the most important thing which I will like to share is that the multidisciplinary culture among the institutions. For that, our institutes have to work hard, and we are facilitating them. We are we have given provision for the merging of the institution to create a multidisciplinary culture among institutions, and they can also start various courses which are not part of the AICTE mandate in their institution. This facility we are providing to our institution to create a multidisciplinary culture. Now, another thing is the credit transfer and entry and exit. We are also working on credit transfer and entry and exit, because we see that 40% courses institutions can take from MOOCs, students can take from the MOOCs, but the credit transfer and entry and exit, UGC has come out with a framework, but framework will be a broad guidelines, and the institutions have to work hard internally, devise their own mechanism, how they will consider the credits, for which one of the easiest way will be to have a MOU with the friendly institutions, so that they can consider their credits. So this mechanism, it has to be evolved by the institutions, and those who are having autonomy, probably I think they must be working in this direction. And one more thing is that the academic bodies, because when this NEP is implemented, these academic bodies, they should be very, very dynamic. If you linger on the decision for 10 days, the purpose of this NEP is defeated. So the role of the institution and the academic bodies is very, very important. And I hope the institutions which are, I have seen many institutions, they have moved way forward in this direction. But those who have not started, it is the time that we can think and we can move forward, whether it is credit transfer, entry and exit. We are also evolving a procedure how a student completing 1 year with additional courses can be given a certificate, or after 2 years can be given a diploma with additional courses. So this type of discussion is going on at various levels, at whether it is UGC, whether it is AICTE or at the ministry. But the ultimate thing which is to be done at the institute level, at the university level. So with all these words, I thank all the participants, all the coordinators for joining this program. I also thank Prem Karla ji, and I will get this opportunity to hear to him today also. Namaskar, sir. Namaskar.
Thank you so very much, sir, for bringing out such an extensive and comprehensive what activities about AICTE and what AICTE has been doing to empower its stakeholders, whether it is teachers or it is students or it is institutions. We are very delighted and very privileged that Professor Prem Kumar Kalra kindly consented to grace this occasion as the chief guest. Professor Kalra, presently director of Allahabad Education Institution, it is deemed to be university. Prior to this, Professor Kalra had rendered a yeoman service to the Indian Institute of Technology, Jodhpur, Rajasthan, as its founder director. He was head of the Department of Electrical Engineering at IIT Kanpur. He also served as Dean Resource Planning and Generation, again at IIT Kanpur. Professor Kalra has done his graduate level education from Allahabad itself, the institution he is directing right now. Having graduated from DEI, and after a very short teaching stint, he joined IIT Kanpur to pursue his MTech. And then he also went on to complete his PhD from University of Manitoba in Canada. After teaching in the United States for some time, Professor Kalra joined the Department of Electrical Engineering at IIT Kanpur, where he launched a research program in the front area of artificial intelligence. And I would like to make a special mention that sir did it in 1988. We are talking about it so many years later. So probably he is one of the pioneers who launched a program a research program in artificial intelligence, making significant contributions in the fields of neural networks. Professor Kalra, one of the principal architects of 3I Networks, a consortium of IIT Kanpur, IDFC, and IIM Ahmedabad, formed with the objective of creating an intellectual critical mass in national policy. Professor Kalra has significant achievements to his credit in research, innovation, industry interaction, and regulatory area. He has published many books and extensively published papers, research journals. He has been assigned the position of chairman, board members of several committees by various institutions in repute, including various IITs. Sir, we are privileged to have you with us and very eager to listen your valuable words. Thank you.
Thank you, Mamta ma'am. Thank you so much. My friend, Professor Rajiv Kumar ji, Mrs. Mamta Agarwal ma'am, Advisor 1, directors, coordinators, and colleagues who have joined this program. It's my privilege to address all of you today. And what I'm going to talk about is very briefly, I believe in basically three trinities. One is that the faculty development program should develop physical, mental, and spiritual aspects of all faculty. That's the most critical part. Secondly, it should also lead to development of values, qualities, and innovations. And lastly, what is becoming very, very important for all of us, looking at the National Education Policy 2020, that how do we actually implement innovations suggested by the government, by the committee of NEP? And I can, on behalf of AICTE, assure you that today AICTE is not a regulatory body, but they are enablers of implementing good practices across all the institute. That has been my experience being on a different committees with AICTE. People are very positive. People are looking for positive changes. And the new initiative which the Allahabad Educational Institute has taken, I think I should share that, because with online education for last 2 years, we are taking now steps that can we teach using music? Can we teach using nukkad nataks? Can we teach using Kathputli? But like, how do you bring in performing art and visual art as a teaching tool? And India is rich culturally for performing art and visual art. Shanti Niketan was one beginning of such aspects. So the Allahabad Educational Institute has also taken the step to establish how do you break boundaries of classrooms, which online education in a way has broken, but how do you still make it very productive and very, very knowledgeable for students? How do you actually bring in virtual labs, what Professor Rajiv Kumar has mentioned, content in various different languages, and content in different ways of expression, like what I call as T's, towards evolutionary art and science of expression. Because today, we believe that engineering mindset is very, very rigid today, but that's what I personally have seen. This mindset has to be broken away. When I was at IIT Jodhpur, I tried to establish IIT Jodhpur without departments. The reason is that there were very few people who could produce or could make them think on interfaces of department. And today, AICTE has taken a very bold step, and I congratulate AICTE members, and especially Professor Shastri Buddhe as under his chairmanship, that we should break away from conventional physics, chemistry, maths, because it's you are becoming a very, very rigid in terms of engineering definition. For me, the engineering definition is and they start solving. And then whatever is needed, they go to classroom and take those courses which will help them in solving the problem. So I think we should appreciate the new innovative steps which AICTE has taken rather than criticizing and sticking to the old road. Because for, basically there was so my suggestion to all of you is try to look at new ways of teaching, new ways of using technology, new ways of actually looking at engineering aspects, because we had started a couple of new centers at IIT Jodhpur. I can give you examples. One of them was system science, which is most popular today and gets the maximum jobs. Second was Coach, Center of Art, Culture and Heritage. How do you bring it together? Very few people are looking art, culture and heritage or art, beauty and creativity as part of engineering. But until unless you create an aesthetics in engineering products, it becomes very, very difficult to actually market them. I remember my Boeing trip in 2008. Interiors of the plane, they have created a new department which was looking at it, and no engineer was there. They were all actually from the aesthetics and beauty and creativity specializations, and they were interacting with engineers and changing their mindset how to look at things, which is very, very important. So I think we have to have a much broader definition of engineering as per se, and the development of faculty also we should do in a very, very broad sense. I think I'm very happy to hear Mrs. Mamta Agarwal and Professor Rajiv Kumarji, that you are actually talking about values, you are talking about qualities of teachers, you are trying to develop changing their mindset, looking at the new way in faculty development program. Because faculty development program is not only about the subject, but developing a personality of a teacher, which influences the students in the classroom. So for my sake, actually, if people have to view it, you have to view it engineering in a very, very broad sense, so that it should become an inclusive discipline. And we should be able to take good lessons or the successful lessons from other streams of what's
Good morning, sir. Good morning, Nandi sir. Can you hear me, sir? Am I audible? Sir, I have made you presenter. Now you can unmute yourself. I think.
Yes.
Yes, sir. No, yes, sir. Yes, sir.
Dr. Jadhav, now
we are honored to have Dr. G.C. Nandi, sir, from IIIT Allahabad. I welcome you, sir. Now I invite Assistant Professor Mohammad Talib Ahmed as a co-host to introduce Dr. G.C. Nandi, sir.
Good morning, sir. Dr. G.C. Nandi is working as a senior professor at IIIT Allahabad in the robotics department. He is expertise in the robotics field. He has developed a technology for AMAL, that is Adaptive Modular Active Leg. He has a dream that at one day, every household will have a personal robot. It will help us in everyday household, cleaning, dishwashing, and doing other jobs. He also wants to develop a robot that will share emotions with us, give us company in old age or in situation like pandemic when our near and dear ones will be away from us in their professional lives. He also wants to develop a technology with the help of knowledge of robotics which can help differently abled persons to live a normal life. With these few words, I would like to Dr. G.C. Nandi sir for the further activities.
Thank you very much, dear, for your kind introduction. So first one, so my lecture will have three parts. First part is a basic one, basic understanding of robotics. And I would like to first play that. And then I will teach you another two myself here. Okay, so please enjoy. I will. So am I audible, right?
Yes, sir, you are audible, sir. No problem. You are clearly audible, sir.
Okay.
सर दिखा रहे आपको शेयर करेंगे तो सर कैसे शेयर करेंगे अच्छा सर शेयर करेंगे तो
Humanoid new area of next 2 hours, I will try to introduce you. Very exciting. And I will also give you enough information, guidance, so that in future, if some of you want to learn more and do research in it, thanks to today's and today date source available in the internet. I will just expose you. But I take this occasion also to thank the Department of College organize such very important way to entire global community problem of protection. Very important. There are two just in the world. They're already big. Steel manufacturing. All kind of precision industry. For example, building of beams of moving aircraft. So all kind of things robot can do the best. Which others cannot do. Those areas work for best. Now, having said that, where new kind of order has marched, a kind of robot, which is humanoid robot, which can collaborate and share the common space with us. And technologically, will there be a difference between this kind of yes and no? The core of the technology, again, this robot will be probable some kind of intelligence. But apart from that, no, because industrial robots are made for their precision. They are very costly compared to what? When a robot, we can develop the technology successfully, will be much cheaper, will be much cheaper. And they will not be so precise. You know, we being a human, not precise. We cannot hold this very precisely, and you will see there is some vibration. I am exaggerating it, but you can do the experiment. Why it is so? Because you see lots of machines, handling the machine, and lot of components inside are very dynamic in nature. Your heart is like something, it's mechanical size in command. This time they're all moving. Okay. Muscles are contracting and relaxing. The internal organs, they are dynamic, and that creates vibration. That's why we are liquid. That's why we cannot manufacture IC chip, or perhaps not same precision in going up or other companies. For this precision job, we may not be, but what we are not at is ourselves as intelligent. Okay. For that, we have our own data. Whether it is true or not, and that we are the most important. And we want to feel not so without having we can do all kinds of things. I can go to some place, I can move around, I can do all kind of activities. So we, for example, on the medical store or railway station, tell any application, any design, which size, which is kind of precision required for industrial robot. Every design so that they can help us in doing day-to-day activities. But as critical as oxygen mask on a patient which wears it, or can we grab some items from the basket without touching each other? All kind of many applications, and world is waiting for us to develop this in there. My aim of the lecture will be to you scientific media so that you can also participate. We need a huge pool of things. You interact and wait. Like catering for many other. We are taking part in all of that. I organizing. My job is to give you the reflection. Those who are interested to know more, I have a YouTube channel, and I will show you. You can just type in YouTube GC master, and it will end up in the playlist. You have foundation of robotics. So under this mathematical foundation of I am developing the course. Now I am for humanoid robot, and view all the playlists you can see. So those materials will be available to you. I will not be there. Okay. So please seriously concentrate, and introducing you with the traffic further you can take help of my channel or any other material. But I'm glad if you subscribe my channel before watching. So with this, what I'm trying to do here, I am trying to take an example of a very simple robot, string manipulator. It is not even qualified to be called as a robot. It has 2 link L1. For representing it, I am formulating a Cartesian coordinate frame, xy, because it's lunar, and say at any instance, and say this is a trajectory robot need to follow. And say at any instant of time, and this is of course moving, just like my hand is moving, assume that this is moving along the trajectory. And say at any instant, it has made an angle theta 1, arm 1 has made an angle theta 1 with x-axis, and arm 2 has made an angle theta 2 with respect to arm 1. That means with respect to x-axis, angle would be theta 1 plus theta 2. This is theta 2, this is theta 2. So this will be theta 1 plus theta 2. Very simple. And then we try to make a relation between Cartesian space and joint space. See how I am, what is x? X is actually projection of this link on x, that is L1 cos theta 1, plus projection of this, that is what x is, right? This one plus this one is the x. So L1 cos theta 1 plus L2 cos theta 1 plus theta 2. Similarly, if you can see what is y? Y is 1 plus this one, that is L1 sin theta 1 plus L2 sin 1 plus. So these two tiny equations you have got from your class 12 level mathematics understanding, right? They're very, very useful actually. See what they are telling. See, what they're telling is at any instant, if I just specify theta 1 and theta 2, then x will be uniquely known. Y will be uniquely known. Okay. It's just like suppose here is a motor, rotating the motor. Here is another motor, I'm rotating the motor. As you rotate the motor, the end effector in call it end effector will go somewhere uniquely. So now if I talk about space, this is my Cartesian space. Cartesian space, and let us construct theta 1, theta 2 as joint space. Now, if theta 1, theta 2 are given, then you are landing up xy. This is called forward kinematics problem. On the other hand, normally what we do, we should command robot here, come here. That means I will specify, go there means what? I will specify xy. Means this will be known. And my robot planner need to figure out to obey that command what theta 1, theta 2 value should be. That means it need to solve this equation. Okay. And you see, unlike the earlier one, now the problem is complicated. Same equation, two equation, two unknown. If xy are given, theta 1 and theta 2 are unknown, then unlike linear equation no more linear. Earlier it was linear, nothing between Cartesian space and this space linear. Why? Because any amount of motor rotation will uniquely place your end effector somehow. However, when xy are specified, then it's a experimental equation, no more linear equation, because cos theta 1, theta 2 are unknown and it's a series. I can expand it. And depending on how with what power term you are expanding, you will get that many solution. So it's a complicated, isn't it? And you see, even for this planar small robot, I can construct a parallelogram. This one, but you understand, huh? This one.
We should command robot, go there, come here. That means I will specify, go there means what? I will specify X, Y. That means this will be known. And my robot planner need to figure out to obey that command what theta 1, theta 2 value should be. That means it need to solve this equation, okay? And you see, unlike the earlier one, now the problem is complicated. Same equation, huh? Two equation, two unknown. Huh? If x, y are given, theta 1 and theta 2 are unknown, then unlike linear equation, since the equation no more linear, earlier it was linear, mapping between Cartesian space and joint space were linear. Why? Because any amount of motor rotation will uniquely place your end effector somewhere. However, when xy are specified, then it's a transcendental equation, no more linear equation, because cos theta 1, theta 2 are unknown and it's a series. I can expand it. And depending on how, with what power term you are expanding, you will get that many solution. So it's a complicated, isn't it? And you see, even for this planar small robot, I can construct a parallelogram. Well, construction of parallelogram was not good. Okay, so this one, but you understand, huh? Sorry, this one. So another set of solution. These are another set of solution which actually solve, give you the, okay. So either this one or that one. These are the two solutions, isn't it? For same xy. So which of the solution you should accept? First of all, the mapping between, when this is given and you require to figure out this is known as inverse kinematics problem. Inverse kinematics problem, okay? And the solutions are non-unique because the non-linear nature of the equations, okay? Although two equations, but since they are non-linear, you will have multiple solutions. As you can see here, there are multiple solutions, okay, for same xy. So then question comes, so this is a typical problem, right? And multiple solution means you will have to select some, you will have to reject some, say which one to select, which one to discard, that will depend on solving some optimization problem. The common sense based optimization would be where the current position of the robot arm is and select the nearest theta values, set of theta values which require less movement of the joints, thereby it will be economical energy wise to run. So out of many solutions, you need to design a screening process where some solution will be discarded, some solution will be taken, right? And how to crank out the solution after all, okay? This is the two equations, you know, it's an elimination, so it's an exercise to you. You do it, and today you can do it. First you can square both the equations and then add, and you will see one solution you will get. Okay, it's very simple, squaring and adding. And the solution you will get, theta 1 or theta 2, try to express them in terms of 8 and 2 function. 8 and 2, say you will be having some, we write like this. The 8 and 2, I have not solved it, it's left for you, but very simple solution, 12 class math again, you will be able to figure out what is theta 1 and theta 2 in terms of 8 and 2 function, okay. What is 8 and 2 function? 8 and 2 is an specially configured arctan function, tan inverse function, right? But it is different from tan inverse. And in robotics, inverse kinematic solution, always I prefer solution in terms of ATAL2 function. Okay, it's a library function in most of the languages, but formal languages. So, but even you can easily, if the function is not available, you can create it. See how? Say I have 4 quadrant. This is the Cartesian XY, Cartesian coordinate frame, second quadrant, third quadrant, and this is fourth quadrant, say. Now I have asked robot to move somewhere, say 2, 2, plus 2, plus 2, okay? Say this is the point. So robot should understand that, okay, this is the angle 45 degree, okay, and this is the place where I need to move, so it will move here. But what if I asked robot to move -2 point, which is in the third quadrant? Robot should be able to understand, and robot should be able to go here, right? But if you use tan inverse function, tan inverse 2 by 2 will give you pi by 4, and tan inverse -2 by -2 again will give you pi by 4. Okay, that's the problem with tan inverse. In robotics, it is better to avoid, whereas ATAL2 actually give you this angle, okay, or that angle. That means 45 plus 90, okay, that is -135, or 225 plus 225, whatever it is, it should give that correct angle. And if you, that will be ensured if you use ATAL2 function. So what ATAL2 function does, it takes the solution from tan inverse and then put the argument of the variable section y to correctly tell you that where robot need to go. So this is the inverse acceptable inverse kinematic solution in terms of ATAL2 function. So you need to figure out first the solution by solving these two equations, okay? And then what? You have a model now, okay? So wherever you specify x and y, this solution will tell you what will be θ1 and θ2. And then robot can actually, a set of θ1, θ2 will be there. Of course, you will see some kind of multiple solution, and you will have to optimize, and you will have to select some, okay? So you can follow the trajectory. Can you? So you can just take so many points on the trajectory point, and corresponding to each point you solve inverse kinematics, and the problem is over. Is it? No, problem is not yet over. Why? Because you see, this is the trajectory. How to follow the trajectory? At what speed? This way or slowly this way? You have not specified in your kinematics model. So you need to figure out what will be the velocity, right? So I need not only Cartesian space xy value to be given to my planner, together with that x dot y dot should be also specified. Otherwise robot will not know at what speed. Are you following? At what speed the trajectory should be followed. To get that, we need to actually have some more. From here we can, again, this tiny equation you can calculate by differentiating with respect to t. You can get this. By differentiating with respect to t, you can get this. So I am not doing, it is very easy, again 12th class math, okay? You will specify this and you will get some kind of, okay, θ1 dot θ2 dot. So this is called manipulator Jacobian matrix. You know, when you have function of several variable, then to know what will be the functional change corresponding to the incremental change of those variables is captured by functions Jacobian, right? Here similar concept is a function of two variables θ1 and θ2. In case of Puma robot, it will be a variable of 6 parameter θ1, θ2, θ3, θ4, θ5, θ6, whatever it may be. So this Cartesian space velocity and joint space velocity is actually can be mapped using Jacobian matrix. How to get it? Just as a assignment. Today you do it. You just differentiate this and figure out what this matrix will be. It will be a 2 cross 2 matrix. Okay, and that matrix will be a configuration dependent, meaning what? At every position the robot move, the matrix needed to be updated. So if you have that, now I am writing more in a vector form. This is equals to this, and big theta dot equal to this. So you will be having this kind of relation, Jacobian and theta. Then not only robot planner need to know what is theta 1 and theta 2, but it need to also know that what is theta 1 dot, theta 2 dot. So this you can figure out just by inverting the Jacobian matrix, manipulated Jacobian matrix, and multiplying it by Cartesian space velocity. So this is very, very important relation, another important relation. So only inverse kinematics will not solve the problem, will not make the robot able to follow a trajectory. It need to have velocity relation. And if you have these two formulation, that is mapping between Cartesian space and joint space, and joint space velocity and Cartesian space velocity, then yes, a robot can actually follow the trajectory. Okay. For that, I need to. So what I will get this theta value, theta dot value, and then I need to just formulate a control strategy so that this value will be executed. But wait a minute, still my model is not very sophisticated. Meaning what? Meaning this is incidentally this is called resolved rate control. Using kinematics, using Jacobian, you can control. That means control means what? You can follow a trajectory, you can do pick and place, all kind of things you can do with a robot. Okay, but the trajectory following will not be very good, very accurate. Like if you want a trajectory like this, maybe robot will follow a trajectory like this. Okay. Suppose this is also a trajectory to write robot's name R, right? And if you just make a resolved rate control and kinematics based control, maybe you will get R like this. If you are satisfied with this, it's fine. Okay, so you can work. But if you are not satisfied, then we'll have to make our model little bit more sophisticated, more realistic. Why it is not sophisticated? Because you see, you have only L. You have ignored mass property of the link. It's not there in your model, right? So we need to, again, starting from here, using Lagrangian dynamics. Lagrangian dynamics, which is energy based. As you know, you need to formulate a Lagrangian function, you need to calculate kinetic energy, potential energy of the two-link manipulator system, or it can be six-link manipulator system, and then you can figure out what is the derivative, and there's Lagrangian dynamic formula which give you cause and effect relation, okay, and you will end up in getting this kind of equation. Okay, this is called dynamic equation. So this is in coupled form, so that means for two-link manipulator it will be like this, for six-link manipulator it will be like tau 1, tau 2, tau 3, tau 6, like that, and everything will be matrix. Okay, so that's why it is in a coupled form. For it will be 2 cross 2 matrix, this is mass matrix. Okay, this will be again 2 cross 1, blah blah, so all these things. So when you do this using either Lagrangian dynamics, or there is another method, Newton-Euler method. Okay, so any method you can use to land up to this kind of equation where cause and effect are related. You see, now if I specify joint torque at the joint, say there is a motor here. Okay, this is realistic robot, right? This is unrealistic because there is no mass. Here there is mass, and there is shape also, right? So inertia matrix will be you will have to determine from here. So this is called dynamic equation of the robot manipulator. And when the torque is given, as a result of that, the hand will move somewhere, okay, hand will move somewhere, is called forward dynamics problem. On the other hand, if I specify a robot that, okay, follow this trajectory with such and such, I will specify theta versus t, theta dot versus t, all kind of thing, right? If I do that, and then also I can specify theta double dot versus t, then I am telling my planner to calculate the torque trajectory which will accomplish my desired theta characteristic, velocity characteristic, acceleration characteristics, all kind of thing. If I specify, then you need to solve this to second order differential equation. But one unfortunate thing is it is not linear equation. It is non-linear equation because you will have sine cosine term here. So incidentally, this is called in terms of torque. I am telling you, assuming that we are talking about robot having all revolute joint. So it is a torque, joint torque. So this is inertial torque. This is centrifugal and Coriolis torque. And this is gravitational torque. Okay. So all these three torques are related with the torque of the motor. So if the motor torque is specified, and as a result of that the end effector is moving with some velocity and some acceleration, then this is called forward dynamics, and this is used for simulation purpose. Okay. For simulation task you can use it. Okay. But if I specify right hand side, but please remember left hand side is given, right hand side you need to figure out is forward dynamics. Here, unlike here, when left hand side was given, it was inverse kinematics. Okay, so my students, you should not make mistake. Normally they do, but you tell your students, right, that when I am talking about dynamics, left hand side is given is forward dynamics. Talking about kinematics, left hand side is given, it is inverse kinematics. On the other hand, if I just give theta dot, theta trajectory, okay, and then I am trying to tell my planner to synthesis torque characteristic to accomplish that is called inverse dynamics problem. Inverse dynamics problem. It is used for manipulator control. Used for control. Okay. So what you need to do here, you see, you need to solve this second order equation, nonlinear equation. Solving is difficult. That's why we linearize it sometimes. Okay, and try to make our model little bit simpler and perform that. So this is more sophisticated model. Although we have ignored, and very difficult to model those things, that we are assuming that individual links are perfectly rigid. So we have ignored any deformation during motion. We have ignored the manufacturing, some kind of manufacturing inaccuracies, okay, which will cause additional disturbing torque. Also, we have ignored joint friction, etc., etc. But nevertheless, this is far more sophisticated model than this kinematics model, right? So, if you have resources, you should use dynamics model for subsequent control. So, you see, at the end of the story, for both inverse kinematics, inverse dynamics, the planner is giving you either stream of theta values theta dot values, or it is giving you the torque values with respect to time characteristic of the torque. So with that, you can actually, so we have talked about manipulated Jacobian. So this is incidentally, you do it and you will get it like this. Huh? Okay. Before I forget, I should tell you that this Jacobian is very, very interesting. It's a configuration dependent, first of all, I told you. And then is inversion you need. You need is inversion, right? To crank out joint space velocity. Now what if the determinant of the matrix is actually 0, and what when it will happen? This is 2 cross 2, fine, but if it is Puma robot, it will be a 6 cross 6 matrix. And any of the row or column, if they are dependent, okay, then the determinant will be 0. And then how to figure out theta dot? You cannot, because whatever value is this, so this will be non-existing and you will not get theta value. This is called singular robot. Those configuration for which this thing happens is called singular configuration of the robot. So singular configuration is bad. Why? Because you see, robot is losing 1 degree of freedom, because the matrix is not of full rank. I hope you know. If you do not know, then see, whenever a matrix is not of full rank, for example, here in a 6 cross 6 matrix, the rank of the matrix should be 6. But if the rank is 5, then his determinant will be 0. Okay, or 4, the determinant will be 0. So we call matrix is not of full rank. Then the inversion will not exist, and then the manipulator will lose 1 degree of freedom. And when it will happen? You see, it will happen when this manipulator becomes a straight, in a straight configuration like this. Okay, so it will move along a circle. Okay, move along a circle as if making this angle pi, as if it is one link. Okay, so this is called singular configuration. Another singular configuration for 2-link robot manipulator is when this is completely folded like this. Okay, and okay, the angle between them is 0. Then also it is called singular configuration. Then also the manipulator is moving just like a smaller 1-link manipulator. So it is the meaning of losing degrees of freedom is this. So these are bad actually. So we do not try to drive robot in a singular configuration. And in the torque space also it can be shown that you require infinitely large torque to drive robot in those singular configuration. So once the Jacobian matrix robot is given to you, you figure out Jacobian matrix for and you figure out what is the working envelope. Yes, another terminology, working envelope. What is the working envelope? Is the space where robot can move very simply, right? But there are so many other issues. Working envelope has reachable workspace and dexterous workspace. So all this complication you will learn during this course. Here in 2-link manipulator, what will be the workspace for 2-link manipulator? Let us draw it. So this is okay. So this is the length L1 plus L2, and this is length L1 minus L2 mod. Okay, so it is a working envelope is a annular space between these two circles where a robot can move. Okay, so this is the concept of workspace. Okay, and Singular space is actually when the angle between them it is moving just like a straight. So this is at the periphery. The robot is moving when it is moving with straightening condition. Okay. So these are singular space. So concept of singularity is I think understood, and you will study in detail in your during your course, I believe. Okay. Otherwise, you can see every topic which I am discussing is there in my video lecture in the YouTube channel. You can study more detail. Okay, I am giving you the concept. So it is very important to find the singular configuration and avoid that singular configuration when you follow a control strategy. In the control space, those joint values should not be there. Okay. So now, little bit about control I would like to talk to you. Okay. So you have kinematics, inverse forward kinematics, inverse kinematics, dynamics, forward dynamics, inverse dynamics, then trajectory planning. Okay. This thing I should tell you that when I am defining a trajectory in the say in the Cartesian space, say this is my trajectory. Okay, this is my trajectory. Yes, this is the trajectory. I have defined the velocity also, and I have asked robot to follow the trajectory with such and such velocity. Okay, so x t and x dot t, so that I have defined. Okay. Now, with that, how robot will know is theta and theta dot, you know, by these two. Okay. But apart from that, it need to actually in the joint level, it need to plan a trajectory. For example, pick and place operation, right? Robot will have a trajectory, and we should make the trajectory very smooth. Meaning what? So not only theta possible, theta dot will be also existing. Otherwise, this kind of trajectory where discontinuity is there should be avoided, because the robot will be broken if you try to follow this kind of trajectory. So trajectory planning is also an issue. Okay, trajectory at the joint level. Given trajectory in the Cartesian space level, how to design or this back and forth. Okay, I should, if possible, in many applications like pick and place and all, not trajectory planning like this, I have an option to design a Cartesian space trajectory in such a way that in the joint space smooth trajectory will exist, and many out of many smooth trajectory, some optimal trajectory I need to figure out, and those trajectory will be my raw materials for control, for execution level control. Okay, so trajectory planning we have already talked. We have already talked with Jacobian. So all these topic, dynamics, kinematics, all these topics are to be taught during or in case of electrical LCR circuit. This is actually perturbation. That is, I touch this is a battery or EMF, right? I will touch upon and I will create a signal, and then it will travel, and I will see how the signal behave, right? So if there is no resistance, only LC, the signal will oscillate and the motion will be simple harmonic. All of you know this is analogous to our mass spring system without damper. And when damper is there, it is LCR circuit. Okay, so this is electrical equivalent. I try to tell you, they are basically same. Okay, technologically. Now suppose I have a block mass M. There is a spring, and here is damper. Okay, and this is the control force I am giving. So what is, I am drawing free body diagram. Okay, using D'Alembert principle, you know. So what is that D'Alembert principle? It tells you that once you have a direction of motion, if in the opposite to the direction of motion, mass time, acceleration, if you attach a force, then the system becomes pseudo-static system. Okay, and all the static equilibrium condition you can apply. So this is a free body diagram where force is acting in this direction, inertial force is in this direction, mass time acceleration. This is damping force, this is spring force. So this is a dynamic equation with control. With control means what? I am trying to design this AF in such a way that I want wherever block will be at particular time, say I want at T1 block should be X1, at T2 block should be X2, at T3 block should be X3, kind of thing, right? Every state, if I would like that block should obey my command, then it is called control, and I need to create that control strategy. You see, this is F is the control force. Now I can decompose the force into two parts. You see, alpha F prime plus beta, where alpha is equals to M and beta is equals to Bx dot whatever, this and this. Okay, why I have done this? Because I do not want to control the entire clumsy second order system. Instead, in doing so, what I have decided that my control force, now new control force, will be just instructed to control a unitary mass system. It's more simple. And in that process, this is called actually model-based control or computer control. There are so many names, and the concept is very, very important, you know. I do not want to control this or this because I know the model, I have made the model very well, and I have sensor. I will show you in the block diagram. With the sensory value, I will just update this value, and I will only control a unitary mass system. So this is my new controller. This is called computed torque methodology or model-based control methodology. So I define error equals to x desired minus x. So error dot will be like this, error double dot will be like this. So if I try to formulate a PD controller, proportional derivative controller, then controller design is a art. You see, I have made this design like this. Okay? A prime will be x desired double dot plus kv error dot plus kp. In doing so, just put x prime x double dot, then you are getting a error dynamics, which is a second order system, and we love it, right? And why second order system? You must make a point here. It's very, very important to understand, because what will be the dynamics? You know, dynamics will be like this. Error versus t. If I solve this, okay, this is a linear second order differential equation. Okay, time invariant differential equation. Okay, I get three types of behavior depending on the value of Kp and Kv. So this gives me a avenue for selecting the gain parameter. Normally we select gain parameter using critically damped situation, because that's the faster. That means whatever command you have given, in no time the command is being obeyed. So this is called critically damped situation. Okay, so this is the characteristic equation of the second order equation. Okay, and you know, this is algebraic quadratic equation, two roots. Okay, and they will be actually by this. So critically damped means kV square equal to minus 4 kP. Okay. So this is underdamped situation when in the Argand diagram. So this is imaginary axis, this is real axis. Okay, perhaps you all know the second order system, as long as these are positive, guarantees you that the roots will be in the negative domain, negative half. Okay, either root could be like this underdamped, like this. Okay, or roots could be overlapping, which is critically damped situation. This and this are same. Or roots could be here. No roots can be here as long as this is the second order system. Okay, that's the beauty. Okay, you analyze why. So from here you can get the gain parameter, and your controller will now work. You see, this is completely clearly to be understood. Okay, you see, this is unitary mass system M, this is my control, and this is the total system, this is my total control force, and out of total control, you see, I have sensing x dot with some sensor, position sensor, velocity sensor I can have. Okay. And since the sensory value is coming to me, I am updating, tapping this and updating these values. Okay, in the system these parameters are there, and just I am not controlling them, I am just updating them. This concept is very, very important. And then it estimate the pose, and suppose this is the goal pose with respect to camera desired. This is actual. Okay, so this is position based visual servo. Okay, so that is being computed in again 3D space. Okay, so in the range space of 3, it is being calculated goal with respect to camera, and then again, just like earlier I have shown you, the feedback loop is going on. This is called position based visual servo. Okay, when you have camera as a sensor. There is another methodology, image based visual servo, where everything is done in the two-dimensional image plane. So this in the range space of 2, it works because feature extraction. So here this block is not there, you see, and instead of that I have a desired feature, I have an actual feature, and we are compensating them. That is the error, we are minimizing the error between them. That's how the control loop works. This is in very simple, but they are the state-of-the-art control strategy in vision-based robotics. One should know, and this is a book where you can study detail. Well, so we have told you about many things, right? Now, robot having controlled also can be imparted supervised and Okay, so can you hear me? All the
Yes,
participants?
sir. You are audible, sir.
Okay. Okay, very good. So I will just. Can you see my screen? Is my screen is visible?
Your screen is visible, sir.
Visible, right?
Yes, sir.
Okay. Good. Okay. So, and if it is there is any problem, network problem, let me know by you can call me also. So, what in the next lecture, 1 hour lecture, what I will try to do, I will try to introduce you with the specific. So there are 2 more lectures, half an hour each, and I will talk about specifically how to model a humanoid robot. Okay. So, is the humanoid robot modeling is entirely different than your industrial robot modeling? The answer is yes and no. Yes, in the sense their inverse kinematics cannot be solved the way we solve in case of industrial robot. What is the reason? Reason is actually the humanoid robot like now. By the way, we have a fleet of now. 3 nows are available. So in our laboratory, and also now has a very very good choreograph software where now is available in a digital space. So the participants can, as a take home, participants can actually write many applications there once you know how now works. Okay. So this now robot structurally is different than robot. That's the reason that, and they do not follow Piper's recommendation. If they are not following Piper's recommendation, then I try to tell you that cranking out inverse kinematic solution, closed form inverse kinematic solution may not be possible. So the way out is to look for algorithmic way which we are planning to solve such humanoid robot and cobot like Baxter, like now. Baxter is an example, nice example of cobot, that is collaborative robot, and now is a beautiful example of humanoid robot. Okay, it is supposed to be in every household. Okay, but is it visible? My screen is still visible. Rambeji? Is this?
Yes, sir. Visual, sir.
Okay, okay. So here you see now robot, and it has 25 degrees of freedom. 25 degrees of freedom, 6 degrees of freedom, and 19 degrees of mobility. Actually.
Please share your screen, sir. It is not visible.
Am I audible or not?
You are audible, sir, but your screen is not visible.
Means my screen is not visible.
Yes, sir.
Okay, I will have to share it again then. Now?
Yes, sir. Okay, sir.
The problem. Okay. So this robot has 25 degrees of freedom, and you see head 2 degrees of freedom, head yaw and pitch, and we'll see shoulder pitch and roll, elbow yaw and elbow roll, hip yaw pitch. This is a shear joint with the leg also, and then wrist yaw. This is then hip roll, hip pitch, knee pitch, ankle pitch, and ankle roll. So for modeling any device or any robot, you need to first know its anatomy. I call it anatomy. And this small video will help you to see how the joints move. Because if the joint is clear, then you can make the model. Just see carefully. This is the freedom of now. We
have a fleet of nouns. Now robot, it's a robot or humanoid robot, whatever you can call it. It has 25 degrees of freedom. And we have divided it into 3 zones. Head zone, it has 2 degrees of freedom, head yaw in each. Then right arm zone or left arm, whatever, it has a symmetry. So it has shoulder each and one, elbow, yaw and one. So how many degrees of freedom? 1, 2, 3, 4, 5. The right leg zone has 6 degrees of freedom. This is interesting. This hip your pitch, 1 degree of freedom. This joint is a shared joint with torso, and then you have hip, roll and pitch, hip pitch, ankle, pitch and roll. So ankle 2, knee 1, 3, 4, 5, 6. So 6 degrees of freedom in the hand. Now let us see those degrees of freedom. Okay. See, this is head. Here we are, and here is pitch. Now, hand. So, see, this is shoulder joint. Shoulder joint has 2 degrees of freedom. One is this, another is this. Now, come to the elbow. This is elbow. Elbow joint. Plus 2 degrees of freedom. It is visible, right? And the 2 degrees of freedom. This is wrist as 1 degree. This one, elbow 2. This 5 degree of freedom. Now to show you leg degrees of freedom, I need to make the robot inclined position, right? So this operation table where I can show you. See carefully. So coming to the hip. So this is actually the joint. This is the joint, okay, which is shared by torso and hip, which we are calling hip yaw pitch. So this is one. Then this is another one at the hip. So this is the axis. Okay. And another one is this is okay. So this is one. This is another one, and that is here you have seen, right? Okay. Now here this comes to the knee. Knee has 1 degree. Okay. And then ankle joint. Ankle joint has then this is an axis, another axis of rotation. This is visible. Okay. Just constraining it so that you can see. So these are the 6 degrees of freedom each areas. But again, as you know, grammatically, not 25 degrees of freedom, it has like 6 degrees of freedom and 19 degrees of mobility. So clear. Now we will show you now in action. We are showing now in action. You have seen already the degrees of freedom. So it's listening. See. Now stand up. Then sit down. So in fact, there is the photograph software. Using that, we can write Prof. talk easily. So it's a lot of sensors. We talk about that. Right now, the anatomy of an arm should be clearly. Well, so after knowing the degrees of freedom in detail, now we are in a position to model the robot. Okay, and meanwhile, I assume together with my 1 hour lecture of introductory lecture, two things you need to know. One is how to represent position and orientation of robot links. So incidentally, these are there in the videos. They're known as DH, Dinovet-Hartenberg principle. This is the heart or kernel, okay, which we will use for modeling. DH principle has been explained in an elaborative way in my series of video lectures, and orientation representation also has been explained there. But today I am giving you the overview only with these 2 hours. Okay, so using Dinovet-Hartenberg principle, one can actually establish kinematic relation between two adjacent joints, and there are process to attach joint. Wherever there is you can see, first you will have to identify the motions, which by video now you know that I have two joint at the head yaw and head pitch. So these are the two joints, and in this joint we'll have to assign coordinate frame in such a way so that the rotation takes place about z axis always. Okay, this is the convention which has been elaborated in DH principle, right? So following that convention, all this this is tricky though, but let us assume that you are smart enough to attach rightly the coordinate frame. Once you are done with that, then this now robot physically computer can forget, and instead computer can have the 4x4 matrices to represent the robot. And the manufacturer, the moment you are buying a particular robot, now only, manufacturer will give you what is the arm length, what is the upper arm length, the lower arm length, what is the hip offset, all kind of, these are called DH parameters, incidentally, DH parameters. So using DH principle, you attach coordinate frame, and using DH parameter, you fill up the DH table, which we'll talk next, and you attach another coordinate frame at the hip of the robot, so that all the joint angles of all the joint coordinate frame and head, leg can be represented with respect to this joint, okay, or with respect to this coordinate frame. Okay, so this is pretty simple one once you know the DH principle and follow the my lectures, and you will be able to get all the matrices which I am going to show you. Okay. Apart from that, now has several sensors. You know, it has tactile sensors. It has two speaker. You know, it can interact. Okay, now can talk. Okay, and it has tactile sensors. There are 10 tactile sensors. Tactile sensors are those sensors which are activated by touch. Okay, and it has also foot bumper sensor, which is another tactile sensor. Okay, so altogether 10 tactile sensors are there. Then on the body, it has sonar sensor, so that it can avoid collision and can know that how far a particular object is. And it has two cameras, although resolutions are not that great, but anyway, and the cameras are not the eyes, unfortunately. So these are the two cameras. You can see now has two cameras, and this is a false eyelids which glows, and you think that camera is here, eyes are here, but those are all false. Okay, but to give an aesthetic
shape of human-like shape. It has been done so. And then it has 4 microphones which detects the origin of the sound and understand what you say. And you see, in case of human, our links are there, and links are operated by our muscles, right? And we, technical term, we call them actuators. 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 Okay. And human, this now has only motors as actuator. But there are many, and mostly all the humanoid robot which has been designed so far, the joints are operated by motors. Okay? And of course, through some transmission devices. But in case of construction robot, in case of other industrial robot, it is possible the robot might have, say, pneumatic actuator, hydraulic actuator. So all kind of things are possibilities. Okay. Now, let us see, since this is a complicated structure, you see, we need to divide it. And this is a well-known principle in algorithm, divide and conquer. Okay, so we just make some chains, head chain. So I isolate head. And then arm, left arm, right arm. They are the same basically. And leg, right leg and left leg. And those have these many joints. Okay, and where from I will get that joints, as I have told, again, read on here for you. Okay, these are the representative of a link. So one coordinate frame representing one link, another coordinate frame representing another. Okay, and DH table you need to figure out. First, somebody will give you the robot, probably the manufacturer or mechanical designer. And then as a roboticist, your job is to correctly attach coordinate frame, okay, following DH principle, which I have discussed in several lectures. So in video lectures, you can, you will have to learn that. Without that, independently, you will not be able to model a robot. Then also, this is very, very most important matrix, which tells you is a 4x4 matrix. In case of robot, this will be always 4x4 matrix. And this matrix we have deduced in my video lecture classes. So if somebody interested, they will have to know that where from this matrix is coming. Okay. But right now here, let us assume that this is a matrix, which is telling you the relationship between ith coordinate frame with respect to just its preceding link, that is coordinate frame I-1. And this is the way DH table is formed. Ith link, and this is called DH parameter, which is twist angle, link length, then distance between two successive link length, and this is variable parameter. Okay, that is the joint motion. Interestingly, for any robot, all the 3 parameters out of, there will be only 4 parameters. The DH principle is telling that with maximum 4 parameters, you can completely deduce a kinematic relationship between 2 adjacent links. So these are the 4 parameters. And seeing this and having the expertise about DH principle, you will be able to fill up this form. Okay. That relation between first link, okay, so you put I equals to 1, so you will get this matrix. First link, position and orientation with respect to ground link or zero link, which has been assigned somewhere here. You see, this is a zero link is here. Okay, we have put. And 0 for the arm. And for the head, zero link is put over here, which has been shown here. And one trick normally we do so as to make the maximum parameters as far
use the same matrix, put all the parameters, and you get this matrix. And then total head kinematics can be obtained by just multiplying this matrix side by side. You see, 2 with respect to 1, 1 with respect to 0, that is, will give you 2 with respect to 0. Now, if this is given 4 by 4 matrix, and you need to figure out this and this to attain this, this is called inverse kinematics problem. So, having understood how head can be designed, you can, in my third lecture, I will talk about how the other parts, entire robot can be modeled. Okay, you see, for that again, you will have to do this similar kind of thing. Now right hand, now left hand, now right leg, now left leg. Very carefully, you will have to fill up this form correctly. Okay, just minutely looking here and reading, listening my lecture or reading book, you will have to understand the DH principle. And once you understand that, you will be able to fill up this form. It's called DH table. They are called that's it. Once you get DH table, then one by one you can use, say, you want to do right arm modeling. Fine. Okay, right arm model. So you start from here. So again, same old story, the way you did for head. Okay. So you are able to get all these matrices very easy. It looks very ugly, but it's very easy. You will have to put this row, all the parameters of this row to this matrix. Okay, so theta is the parameter, motion parameter. Alpha is the twist angle. Then AI is actually the common normal, which is characterizing the linked length. And DI is the distance between two successive common normal. And this is the motion parameter. So all this you can, you can, if you do it correctly, then you will be able to reduce. And this is actual model. We are talking about model, because once you correctly got all this, so this is for arm, right? Right arm. Similarly, there will be for left arm. It has 5 degrees of freedom, so you need to get link 5 description with respect to 0 description. 0 is here, you see. 0's link is attached here, okay, as you can see. So you will be able to get this model. This is called the kinematic model for now right hand. In this exactly similar way, you can deduce kinematic model for now left hand. And once these models are perfectly done, you see, then you can program, because now computer need not understand anything about the physical load. Computer can very easily, you have a data structure to represent matrix using array, okay, using NumPy in Python, you can easily encode all these matrices and you can formulate forward kinematics problem or kinematics problem. And then depending on if this is given, and you need to figure out theta 1, theta 2, theta 3, theta 4, theta 5, this becomes your inverse kinematics problem. And if you just move all these joints, okay, by some angle, okay, and you can actually get this is your forward kinematics problem. Forward kinematics problem is normally used for designing the working envelope. That means where now can move and simulation purpose. The choreograph software and the industry person mostly try to exploit forward kinematics as as possible, as far as possible. Okay. And a programmer, as a programmer, you can just program 5 nested loop, because every joint, so this is has say theta 5 minimum, theta 5 maximum. So theta 4 minimum to theta 4, theta 3 maximum, theta 2 minimum, theta 2 max, then theta 1 minimum, theta 1 maximum. Because you know, like our joint, I cannot move my elbow 360 degree. So every joint in case of a robot has some limit, and which will be given actually in your manufacturer will give you. You see here. So every joint has some limit, and every joint that will be given to you, and with those you will be able to run the loop, 5 nested loop, and you can generate enormous data with that 5 nested loop by running those loop and collecting the data. And that will be, and if you now design a surface along those data, then it will be a working envelope of the robot. Okay? So this is the some strategy I told you how to develop the model. And now suppose now robot is instructed to move from one place to another on a floor. Now knows with respect to this inertial coordinate frame all the address, it has all the address now after modeling of each joint, head, where is head, where is any joint of arm, where is leg joint. So everything it knows with respect to this coordinate frame. This coordinate frame, which is we have attached at the torso. But that is very, very important because once you know that, then you can attach a coordinate frame anywhere on the floor where you are, so that is a fixed coordinate frame. And now robot need to move somewhere. You are telling that go from place A to place B. Okay. So now robot need to know with respect to this floor that where it is at present. Then floor has the information about A and B. So this information can be gathered, and this even the floor coordinate frame, by attaching a camera on a particular room where now robot can move in an autonomous programmed way. Okay, so now can know so that A and B in this camera coordinate frame, and then using a algorithm called simultaneous localization and navigation. It's called simultaneous localization and mapping. Simultaneous localization and mapping problem is an algorithm that basically tries to figure out with respect to some landmark where it is at present and what is the map. Once it can locate itself on the map, it can locate in the map where is the destination, and once it knows where is the destination, it can find a path, it can figure out a trajectory. Okay, and if some items are there, it has to design a collision-free trajectory. So all kind of detailed algorithm development issues are involved there. But this is the way, once you model it correctly, the robot will be able to move as desired by you. Now leg. Designing now leg is although similar, but you will have to be careful because stability is an issue, because now is a biped robot like human, and biped structure is inherently unstable. Why? Because as you know from the physics itself, so it's an inverted pendulum like of structure. Okay? So our head is big and our leg is just like this. Okay, so it's an inverted pendulum structure, and those who knows physics a little bit, you know that it is inherently unstable. Unstable means putting it in this position, you always need to have a control torque here. Otherwise, it will be slightest perturbation is giving
it will be disturbed from the mean position of equilibrium, which you want to be here, right? So this is inverted pendulum. So now structure is just like an inverted pendulum. Our body structure is just like an inverted pendulum. On the other hand, see, in the physics you have seen simple pendulum. Okay, this is very stable. Okay, this is mean position of equilibrium. So if you disturb it after some oscillation, okay, it will oscillate and it will come back here. So this is inherently simple pendulum, is inherently stable. An inverted pendulum is inherently unstable. So you understand that, right? And to make that unstable structure stable, we now need to generate continuously torque, okay? And that stable torque is generated by mounting a gyroscope. Actually, by gyroscopic action, now at the belly, if you open, there is a gyro rotor, always rotating at high speed. And in the video, I was a little bit scared that when I asked now to stand up and sit down, okay, I was trying to hold the robot, but nothing like that. It is extremely stable because of the gyroscopic couple, which is produced by the gyro rotor, which is at the belly. If somebody opens now's in the anatomy class, now's belly, you will be able to see. So whenever you switch on the robot, that gyro rotor tries to spin, and direction of the spin is in its vertical position. And by gyroscopic action, it will try to maintain that position always. So nothing to be worried, now will not fall down. And now you have leg kinematics, leg model, just like arm model, you can prepare leg model, and you can figure out the trajectory, okay, that for walking, how much knee joint should move, how much hip joint should move, how much the heel should make the yaw, all kind of thing you'll have to plan. And once you plan correctly, now we'll be able to walk very stably without falling. Okay, so this is a little bit tricky, and you will learn slowly. And next, about control, I will introduce you with the control. Now has Intel Atom processor. This is the specification. It has 2 GB flash memory plus 8 GB micro. So they are not so great compared to a computer what we have. But remember, now is a computer having legs and hands. It's a mobile computer, right? So, and with Wi-Fi, it can be connected with a host computer, and it can be connected with the cloud also to fetch some information. So all high-end activities you can do over there, and low-end execution level activities, performing execution level activities, this the processor which is there in the now is good enough. So now has now QI, that is the Gentoo-based built-in OS, and then we have also as a alternative Now Lab, which is a middleware library for developing robotic application in C, C++, Python also. Okay, so I would like that you should be able to program in Python. So, and now you will be able to visualize how now is working. The robot is, humanoid robot is working. So onboard computing facilities are there. So it has camera also. So vision take image, and this audio, it makes sounds, and motion. This is very important, because vision, audio, those are the sensor information will be collected. But what action has to be taken, that will depend on the motion control. Okay, and that's here. And I will elaborately tell you that this is the CPU board, and all the sensors are connected, and we have USB port, you have R232 port also, so that it can you can attach more, communicate with the norm and attaching more sensors possible. Okay, and then you have ARM processor, which is execution level controller, and which is kept at the chest. Now try to please understand. Now has been imitated vaguely though. Human being. We have two processors. One is our head, that is the cerebral cortex,
which do all kind of planning activities. And behind that, we have a spinal cord who actually does execution level activities. It listens to the planner and do whatever planner is telling it to do. So similarly here, see, this is the planning level CPU, the main computer, and execution level advanced RISC processor, ARM7 microcontroller is there at the chest. So there are ports which are controlling head, shoulder, elbow, wrist, hand, okay, all kind of thing, pelvis, one motor. So all the motor are being controlled the way I have told you in my control strategy class in the first lecture, PD, PID control. So who is computing all this? This execution level controller. And there is a great interface between execution level controller and planner level controller. The interface is a must, and designing interface is a tedious job, but it is required job, because that gives the address of all the joint motors and the joint processor. Each joint motor is equipped. They are not ordinary motor, right? Each motor costs something like 50 to 60,000, where ordinary motor costs 500 rupees. So they are servo motors. Okay, this is servo motor kind of thing. Or nowadays in many robot industrial AC servo motors are also available. So that means they are controllable. They are equipped with sensor, and interface acts as a orchestra controller and tells the CPU that when to pass on the message, and when its command is executed by all the motors, then only interface will tell boss, give me another stream of data, and then it will do. So in this way, in a coordinated fashion, the robot actually moves in a programmed way. And it has a choreographed software, as I told you, and beneath the software, you have several functions. Behind the functions, these are the matrices which I have talked. Okay, so you can have fun with now robot. If you have, if you do not have, do not be upset. Even today, for 1 month, we have the license version, but for 1 month, you can get a free choreograph software, where now will be appearing, if the humanoid robot will be appearing, and you can have a lot of fun stuff, a lot of serious stuff after listening this lecture. If you also subscribe my channel and listen, today itself I have uploaded some more video, because we are trying to now, it's a semester course now I am running, and now student, I need to tell them how inverse kinematics problem has to be solved. That is entirely different from the industrial robot way. So this humanoid robot has some specialty, and you need to know, because in future, COVID situation has showed that how vulnerable we are and how helpless we are in a critical situation. There was no doctor, no caregiver, because all on a sudden there was a surge of patients, and you can overnight create some bed, you can overnight bring some oxygen cylinder, but in this crisis situation, you cannot create overnight caregiver or overnight doctor. So at least in some level, up to that level, the care can be given by humanoid robot. For example, putting mask or putting oxygen cylinder. Okay, you don't need a great doctor to do all kind of stuff. For those kind of stuff, we can automate. And not only that, we can automate in the departmental store. Okay, because you need to maintain the social distancing, and work is going on in this regard. Amazon already has a Amazon Go, that is a shop where completely automated. You have a QR code, you can enter in the shop. They are now, that is not implemented yet, but in future they will be implementing this. But I have visited Amazon Go shop, and I have seen that you can pick up all the materials which you want in the cart. They are also planning to have a robot, so that you don't have to touch the items even. So you will program using your mobile phone or maybe anything. Programming should be very simple. By the way, choreograph software doesn't require any programming skill. Okay, you can just plug and play and can crank out many behavior, complicated behavior to the now. So this kind of robot also can find application in departmental store and many other areas. So with a hope that in someday this will be a reality, we need to develop the technology for that to make it happen. And we are working seriously, and this type of course is very important. At least you will be exposed to the challenges and how the challenges can be solved. And my basic purpose was to make all the videos so far free. It was to create a critical mass so that people will freely can, even with your mobile phone, with your laptop, you can listen to those lectures and get some knowledge and take part in technology development. With this, I will stop my lecture regarding modeling of humanoid robot is concluding. If you have any question, I am ready to interact with you. Thank you for your attention. Stay safe. Is there any question?
Participants, if you are having any questions, you can ask through audio or through chat box as well.
So I see some question. Yeah, please can you read? What is that question? Alauddin is having some question. I think some participant has some question. No? So if am I audible?
Yes, sir, you are perfectly audible.
Okay, great. So some question somebody is asking, is there any really?
Yes, sir, we have a question in
Yeah,
our chat.
please fire it away. Go ahead. बताइए.
Question is from Harish Shankar Kumar. He is asking, I want to perform some network analysis, neural network analysis for inverse.
On inverse parameter solver. How can we get data set for training and validating? Yes, that is a very good question. And in my lecture, I have already talked in the initial, if you see the YouTube videos, this is a very interesting question. First, you will have to make a model, kinematic model, using forward kinematics. And you will have to create data. How? By running loops. I told you if it is a 5 degrees of freedom robot, you run 5 nested loop and collect data. And with those data, you can train a neural network. And we have successfully done it, very successfully done it for 2-link robot manipulator. With 3-link robot manipulator, well, it was still working well, but as the degrees of freedom increases, it will be very difficult because the underneath nonlinearity, because you have transcendental equation using sine and cosine. Underneath nonlinearity learning by a neural network is a difficult one. We are also trying deep learning methods to solve such problem. But as a beginner, you can start neural network analysis for inverse kinematics. Do it for 2-link robot manipulator first and see how it works. So for 2-link manipulator, 2 nested loop you will have to run to collect data. And for training and validating, of course, because you have data, you know that this angle motion will lead to end effector there. So you see whether a neural network is able to do that.
can validate it also. Okay. I hope I answered that question. Any other question? Can the participant speak? No. Ask question by speaking? No.
Participants, you can ask your question by raising your hand as well. You raise your hand and ask your questions verbally. I hope I'm clear and audible.
So no hand is raised or okay. Kindly refer any book or complete design and development of humanoids. Okay. So the book I will have to write, and you see, the technology is changing. Okay. Nowadays, people are not getting knowledge from reading books. Yes, books. Humanoid robot में जो लिखा गया है, there are one Japanese writer, and in my website you can in my website www.gcnandi.com, if you it will land you to my website, and then you click the bottom left hand button, that is materials for my student. If you click, so maybe I will show you. Okay, so if you go there, see www. Okay, so you have landed with my website, and then useful links and study material from my students, for my students. So that is a humanoid robot. Okay. So there are so many materials available, and also the best thing is what I told you. What I told you to visit the YouTube channel, my YouTube channel, and things are changing nowadays, because you see, if you see, in our time we were looking for books. Now people are looking for audiovisual medium because they have more appeal and more ease. That's why we were doing lecture series, video lecture series. Those are will be very, very helpful if you follow them. Okay. For that, you need to subscribe my channel or any other materials. I do not know, okay. But there are number of books. Okay. And the books which I use as a textbook for teaching robotics is Introduction to Robotics by John J. Craig, and another one, Robot Vision and Control by Lee, Fu, and Gonzalez. These are the three authors who has written this book. They are fantastic textbook. Apart from that, video lectures. There is no one. I cannot say one book in humanoid robot which you will be able to read and get knowledge about humanoid robot. Any other question? So I believe with this, we are coming to the end of my session. And today there is enormous possibility of learning if you want to learn. And I will be present always, not physically. If you have question, you can raise your question after listening. All the constructive comments can be there in my video lectures, and I will answer them here. Okay. In machine learning, in robotics, the video lectures you can refer to. With this, I am saying you goodbye. Thank you.
Thank you. Thank you so much, sir. We are very grateful to have you in our session. And as you have started from the very basics of robotics and reached up to the level of how the robots are working, right? I'm going through the few topics that you have discussed flawlessly. Those are how to make a robot work and manipulator control. Next, you discussed about modeling a humanoid robot and demonstrating the actual robot, how it's actually working. It was fabulous. It was definitely fabulous, and knowledge you flourished. That was. Am I audible?
Yes, yes, yes. You are
Okay.
audible perfectly.
Okay, thank you, sir. And next, we have seen that NAO type of humanoid robots, and
Yeah.
next thing was forward kinetics for NOA robots, and it was a fabulous, fabulous demonstration, sir. The demonstration
So
part was very nice. I
great,
would
great.
like to say.
So many such materials will be available in the net also, and then please tell your all your participants to subscribe the channel. Without subscribing,
Yes,
one should not.
yes, I was about to ask this, sir. With your permission, would I share your YouTube channel link with
Yes,
the
yes, yes. So far it is
WhatsApp group?
free. So far it is free,
Thank you,
and we are
thank you,
developing.
thank you.
So, but they should subscribe before watching. That is a ethically correct one. Okay. So, and
Yes,
subscription does not require any money. Okay.
right,
So,
right,
okay.
right. Thank you,
So
sir.
have a
Thank you
great
so
day.
much. We are
Thank you.
very, very grateful to have you in our
You are
session.
welcome.
Thank you
You are
so
welcome.
much, sir.
Bye bye. Bye bye.
Okay, thank you, sir. Now we are having break for lunch session, and that the timing is from 1:30 to 2:30. Means of 1 hour we are having a lunch break. So hope you will rejoin our session and conduct the and share your suggestions as well. Thank you. I'm signing off.